In a world where cocktails are the life of parties and a glass of wine can melt away the day's stress, have you ever stopped to ponder, what's alcohol really doing up there? Sure, there's the buzz, the laughter, the forgetting of woes. But behind the scenes, in the very fabric of your brain, alcohol is pulling some strings that you might not be aware of. Today, we're going to uncover the 7 astounding ways that alcohol reshapes your brain. You might think twice before pouring that next drink. And just before we get into it, if you want to get access to a free video training that shows you how to get immediate control of your drinking, please go ahead and click the link in the description. You'll put your name and email address in, and then a new video will start playing that really shows you a different way of getting in control of your drinking. It works if you've already tried things like AA, therapy, rehab, it doesn't matter. It's completely different. So go ahead and click the link down below. And now let's get into the video. So firstly, how does alcohol penetrate the human brain? So ethanol, what we call the alcohol molecule, is a very light molecule. It's also highly soluble in water and fat. For this reason, it can penetrate into the vast majority of human tissue, including, unfortunately, the human brain. You see, nature has put in place a wonderful instrument called the blood-brain barrier. This prevents harmful substances that are in the rest of the body, for example, through food, from reaching the brain. Now, sadly, because of its chemical structure, ethanol can cross the barrier with ease. And once inside the brain, it unleashes havoc. So first up, we've got brain shrinkage. And this is perhaps the most striking effect of ethanol on the human brain. And it's also the simplest to understand. Because ethanol is a neurotoxin, over the years it leads to the death of so many brain cells, or neurons as they're called, that literally shrink the brain size. Scientists describe this process in various ways. Some call it an atrophy, other times you will see it referred to as premature aging. And no matter what you call it, the fact is that over the years, the brain of heavy drinkers becomes smaller because so many neurons have died off. If you actually weigh the brains of deceased heavy drinkers and compare it to healthy controls, you can see that on average, they can be around an ounce lighter, which translates to countless numbers of dead neurons. And generally speaking, once a neuron can die, the brain cannot replace it with a new one. No part of the brain is spared the shrinkage, but some areas are hit especially hard. These include the frontal lobe, which underlies our so-called executive functioning, as well as deep structures like the amygdala and the hippocampus. These latter areas are linked to the processing of emotions and the formation of memories. All of this is disrupted in heavy drinkers. After stopping drinking, our brain is able to recover a large part of its lost mass. In all likelihood, this happens not by new neurons replacing the dead ones, but with the existing ones increasing their connections to other neurons. But even though the brain of a recovered heavy drinker can recover a lot of its mass, it will never have its previous resistance to ethanol. Even a relatively short-lived relapse is enough to make these people lose all of their gains, rapidly reverting their brains to the previous shrunken state. Now, next up, we've got myelin decline. So, the shrinkage that we just described is easily visible if you image the brain with something like a CT scan or an MRI. Now, other changes are less visible, but equally important. And one of the most recent effects that scientists have discovered is particularly alarming. Our neurons communicate with each other with so-called axons, which are long, thin structures that are similar to electrical wires. And the insulation on these natural wires is provided by a fatty, whitish substance called myelin. Without myelin, the axons cannot actually send signals properly. In diseases like multiple sclerosis, where myelin is systematically destroyed, the end result can be paralysis and even death. Today, scientists now know that heavy drinking compromises the microstructural integrity of this myelin protective layer. They can now objectively measure this decline using an advanced new MRI technology called resonant diffusion tensor imaging, or DTI. I won't go into details here, but the method allows researchers to derive an objective numerical value of how well axons are transmitting signals and how well their protective myelin layer is functioning. Sadly, heavy drinkers show consistent deficits in this measure compared to healthy controls, and DTI allows scientists to spot these deficits even in brain regions that don't appear shrunk on a standard MRI. The significance of these findings isn't clear yet, but it's very possible that this microscopic myelin decay contributes to deficits in attention and working memory. We'll have more on that soon. At number 3, we've got neurotransmitter imbalance. To communicate amongst themselves and with other organs in the body, our neurons use a variety of chemicals. Collectively, these are called neurotransmitters, and there are several dozen of them. Now, the problem is that chronic alcohol consumption severely disrupts a number of these neurotransmitters. The activity of some of these neurotransmitters is artificially enhanced, whilst others are artificially depressed. Think of it like alcohol artificially pushing the brakes on the activity of one neurotransmitter while going full throttle on another. Over time, the brain learns to anticipate this external interference and increases or decreases its own production of neurotransmitters accordingly. For example, one of the most heavily affected neurotransmitters is a molecule called GABA, which regulates our anxiety levels. Drugs like alcohol or benzodiazepine, which artificially stimulate GABA, can lead to a temporary state of relaxation and lowered anxiety. Now, because of this constant artificial stimulation of the GABA system, our brain is eventually forced to decrease its natural GABA activity. This is called GABA downregulation. Just think about it this way. In response to alcohol going pedal to the metal, our brain then puts the brakes on this GABA system, and the whole thing manages to limp along, engine blasting and brakes screeching, but moving nonetheless. But then, when the person stops drinking, for whatever reason, there is no longer anything to artificially stimulate GABA, and the GABA downregulation is exposed, leading among other problems to elevated anxiety, irritability, and insomnia. Alcohol is special among other drugs in just how many neurotransmitters that it affects this way. Apart from GABA, these include glutamate, serotonin, and dopamine, and probably others that we aren't even aware of yet. Some are downregulated, whilst others are upregulated. In one sentence, the natural balance that our various neurotransmitter systems should have is lost. Everything becomes like a tangled mess. At number 4, we've got a distorted reward system. Now, we mentioned dopamine as one of the affected neurotransmitters. Though it's one of the less common neurotransmitters in the brain, dopamine is nevertheless a critically important one. It's a key neurotransmitter of one of our brain's so-called reward system. This is a neural circuit that regulates how we perceive and reply to rewarding stimuli, so-called reinforcers. These are things in our brain that our environment have been beneficial to our survival and reproduction through our species evolution. It's for things like food and sex. Because food and sex were necessary to our survival in the past, we have evolved to perceive them as pleasurable and we seek them out. The reward system is part of the reason that we want and enjoy things like tasty food or attractive sexual partners. Alcohol, in common with other recreational drugs, artificially stimulates this very same reward system. It hijacks it, delivering a massive reward without any effort. This property of alcohol is critical in getting drinkers hooked. We drink more because it's rewarding. Eventually, however, alcohol can stop being rewarding. And at that point, we drink mainly to avoid the negative and withdrawal symptoms that come from not drinking. But it's all caused by drinking. Sadly, by that point, drinking has managed to bring about a so-called reward dysregulation. This means that alcohol has crowded out natural reinforcers, making them less rewarding. Which is why heavy drinkers often go around getting less rewards from natural, life-sustaining reinforcers compared to non-drinkers. So, after stopping drinking, things will only get worse before they get better. At that point, the dysregulation of the reward system is completely exposed, often leaving the person unable to derive any pleasure from life. The inability to derive pleasure from life is also observed in other people with compromised reward systems, for example, schizophrenics. At number 5, we've got nutrient deficiencies. So another way alcohol impacts the brain is through chronic deficiencies in certain vitamins and minerals. Now, there are two possible ways in which these deficiencies can appear. One is through poor nutrition. It's no secret that heavy drinkers don't exactly have the healthiest of diets. Think about the last time that you were drunk and found yourself craving some broccoli or Brussels sprouts. Probably didn't happen. Now, the second way is related to alcohol blocking the absorption of certain vitamins and minerals. Scientists haven't yet figured out exactly what role each of these two mechanisms plays in the various vitamin and mineral deficiencies. But what they do know is that heavy drinkers are routinely deficient in certain nutrients that are key to the proper functioning of the brain. Chief among these is vitamin B1, also known as thiamine. Thiamine isn't synthesized inside the nervous system. Instead, it has to cross from the gut to the blood and from there to the brain. And this absorption process is seriously impaired in heavy drinkers. The early symptoms of thiamine deficiency include weakness, fatigue, and emotional problems. If left unchecked, this deficiency can lead to a type of premature dementia, and I may pronounce this incorrectly, but it's called Wernicke-Korsakoff syndrome. The symptoms include confusion as well as problems with movement and vision. Early on, this is partially reversible. The longer the person keeps drinking, however, the more permanent the damage. Now at number 6, we've got generalized cognitive impairment. So all the structural and chemical changes that we've discussed so far obviously take a toll on the mind. Even if things don't reach the point of full-blown Wernicke-Korsakoff syndrome, it is simply not possible for the brain to sustain so much damage without any consequences. And the consequences for most heavy drinkers are a wide range of cognitive deficits. In the early stages, you can typically only detect these deficits through specialized neuropsychological testing, but as they grow and become more severe, they can have a significant effect on a person's daily life. More or less every cognitive domain that you can think of is deficient, some more than others. Different studies often come up with different results, partly because they use different assessment methods and partly because they study different types of drinkers. But a general consensus is that some of the most affected domains include working memory, processing speed, verbal fluency, verbal learning, spatial cognition, social cognition, for example, the ability to understand emotions in other people, and executive function. Now, we saw executive function earlier, where we mentioned how alcohol erodes the frontal lobes of the brain. But what exactly is executive function, and why should we be interested in it? Well, the term refers to our ability to take stock of things, evaluate alternative courses of action, and make plans towards our goals. And when you have a drinking problem, executive function is the last thing that you want malfunctioning. Drinking basically creates a nasty loop where the more that you drink, the more that you compromise your executive function, rendering you less able to pull yourself out of the hole that you've already dug yourself into, which is pretty sad stuff. Now at number 7, we've got alcoholic dementia. Now as harsh as this may sound, widespread cognitive deficits are actually a kind of best case scenario for heavy drinkers. Now many of them will have it even worse. We mentioned the Wernicke-Korsakoff syndrome, but this is a specialized case. More common is so-called alcohol-related dementia, which is basically when the brain gives out completely. Dementia is a polite way of saying that somebody has gone senile. They can no longer remember properly, perform basic tasks, and function self-sufficiently in society. It is a tragedy. And when you actually look at the statistics of how often alcohol can lead to dementia, the numbers are absolutely shocking. According to one study, alcohol may contribute to nearly a quarter of all dementia cases. I'm talking about 1 of every 4 dementia patients across the entire population. And when you look at older cohorts of heavy drinkers, again you find that almost a quarter of them will have some degree of dementia. Sadly, at this point, even if the person stops drinking, there is no guarantee that the dementia will reverse. And guys, if you click the video on the screen now, you can learn why a drinking problem exists with a totally new way for you to get control.